Welcome back to integrated review for 1.5. In this lecture video, I got few example that I'm going to show you on how we can use linear equation to solve application problems. These three example is what I so-called the comparison problems. Okay, so if I'm only need to comparing between two items, the very first thing we do is find the sentence that contains the translation words. Okay, so rather than saying, think about what it says, what we're going to learn to do here is learn how to find the sentence that contains the translation words. Then from that sentence, excuse me, excuse me, from that sentence, you get two items that are being compared. Okay, if you can find that translation words, then from that phrase or sentence, you get the items. You get the two items that are being compared. So once you identify those two items, whatever which item is listed at the end of that translating sentence is always gonna be X. Translate for the other item. So this is very similar to what I show you here about the football helmet jersey and the perimeter rectangles. All right, so let's read this, okay? It's one sentence at a time. The selling price for a classic car is 14,000. Okay, so that sentence does not contain my translation word like more than, less than, times, product. What was the car's original price if the current selling price is $2,500 less than? See that word less than? All right, less than 3 times original price. So whenever you find the translation word, okay, then you need to be able to you need to know who is less than who. What are the two items? Where is that sentence begin and the end that I need to translate? Who is less than who? What we know is trying to say less than the original price. So if you go back, who is $2,500 less than? Well, it's right here. If the current selling is $2,500 less than 3 times original. So that means what I'm comparing is the selling price and the original price. Okay, that's what I'm trying to compare. I'm not trying to compare two different classic car. I'm trying to compare a classic car, the current selling price versus the original price. So the selling price versus the original price. All right, so once I identify the two items, the item listed at the end, which is the original price, will always be X. Let's go back and translate for selling price. Selling equal 2,500. All right, 2,500 less than. All right, subtraction sign in front. What I just wrote, 3 times 3 times who? The original price, which I already call it X. All right, so far all we did was translate for the two items. Okay, we have not yet set out the equation. So how do I write out the equation? Well, the problem actually told you already how to write out the equation. That's why our job is mainly translate for the items. If you go backwards to be in front of what I highlighted, what was the car's original price? So that's the question itself. Okay, who I need to find? I need to find the original price. So if I go a sentence before, then this got to be the only sentence tell me how to write out my equation, which it says literally the selling price for a classic car is $14,000. So it says selling, come on. It says selling is 14,000. And what I just translate for the selling price is 3x minus 2,500. So that is means equal 14,000. Voila. That's how we write out the equation. Literally tells me. So that's the reason why the first thing we did here is learn how to translate for the items so we know how to write out the equation based on what the problem says. All right, let's solve for this real quick. My only variable term is 3x, so let it stay there on the left side. Move the 2500 over. So that's 3x, still 3x equal to 14,000. Negative 2500 come over, it becomes positive. So let's see, 14,000 plus 2500 is 16,500. Equal to 3x, divide both sides by 3. My answer, $5,500. All right. So x equal to 5,500. X in this problem representing the original price. So the question is asking for the car's original price. So my answer, original price is $5,500. There you go. All right, let's look at another one, okay? The total cost of jacket and the tie, all right, was $70.71. So that sentence does not contain any translation word. If the price of the jacket was $5.09 less than. So once I find my translation word, then that's the sentence I need to translate. So to know where the sentence begin and end, I need to know who is less than who. Who is less than who? Well, I'm trying to compare it with a tie. So who is comparing with a tie? The jacket. The jacket was $5 less than the tie. So the two items being compared here is jackets and the tie. All right, since the tie is listed at the end of the phrase, so the tie is X. All right, let's go back and translate for the jacket. Jacket was $5.09, 5.09. Less than means subtract. Subtraction sign going in front. Less than who? Less than the tie. X. All right, so I translate for my two items. If you read after the word tie, what was the price of the jacket? So that is what the problem want me to find. So I need to go back to the very beginning of this problem. The total cost of the jacket and the tie was $70.71. So that sentence tell me how to write out the equation, because it literally says the total cost of jacket and the tie was $70.71. So that means the jacket plus the tie together is $70.71. There you go. So now we just write down what we translated and solve for X. What did we translate for the jacket? X minus $5.09 plus the total cost plus the tie, which is X, equal to 70.71. So once we write out the equation, now we just solve it like a regular equation. So combine like terms on the left side, because none of the terms has parentheses. And the left side, x and positive x can be combined as 2x. Negative 5.09 still there, equal to 70.71. All right, now I'm going to move my $5.09 to the other side. So that will be 2x equal to, let's see what that is, 70.71 plus 5.09. So that will be 75.80. All right, divide both sides by 2. My answer, x equal to 37.90. All right, x, so x equal to 37.90, x representing the tie. So the tie is 37.90, but this problem is actually asking for the price of the jacket. So x minus, so the jacket is $5.09 less than the tie, so that will be 37.9 minus 5.09. So let's see what that is. So in the calculator, 37.9 minus 5.09. So the price of the jacket, $32.81. And that's my answer. It just wants the jacket. All right. Now, those two examples are comparing between two items. When it comes to comparing more than two items, we do it slightly different. We literally got to compare them now. So on March 17, the Brady family received 35 pieces of mail consisting of ads, letters, bills, and magazine. So that right there already told you how to write out the equation, because these ads, letters, bills, and magazine together is going to end up to be 35 pieces of mail. So that will be ads plus letters plus the bills plus the magazine. Together, it's going to equal to 35 pieces of mail. Okay, so now our job is to translate for each item. So when I'm comparing more than two items, who need to be X? Well, we need to compare them now. We need to actually compare between these four items. All right, four items is like four terms. Okay, if you got four terms, if you hold up four fingers, you know there's four fingers because you have three different spaces between them. So to translate for four items, you're looking for three different phrases, just like the three different space. Looking for three different phrases you need to translate. So let's go. If they receive the same number of ads as bills, that's the first one. Same number of ads and bills. Three more, see that word more than, three more letters than bills, comma, five more magazine than letters. There you go, right there. So that's your three you need to translate. How many ads did they receive? So the question is looking for the ads. All right, so let's translate, okay? To determine who is X, you got to actually compare them. The one in yellow says ads is the same number of ads as bills. So ads and bills are equal amount. Three more letters than bills. So the letters is bigger than bills. Letters is bigger than bills, which is bigger than ads as well. Five more magazines than letters. So magazine is even bigger than letters, which is bigger than ads and bills. So once I know who is the smallest, then we let the smallest one to be X. Well, since the ads and bills are equal amount, that means these two items are both going to be X. All right, so let's translate for the next greater one. The next greater one is letters. So let's find the sentence contains letters, which is right here. Because, well, the other one also have letters, but I want to compare letters against my ads and bills. So three more letters than bills. So that means letters is 3. More than means plus. More than who? The bills, which I already called it to be X, right? All right, now let's go back and translate for the largest amount, which is magazine. Magazine says 5. More than means plus. Magazine is 5 more than who? Than the letters. And what did we just translate for the letters? We just translate letters to be 3 plus X. There you go. That's a catchy part of this problem. Magazine is 5 more than not X, but what? But the letters, which is 3 plus X. So if you quickly combine like term, what's 5 plus 3 plus X? What's 5 plus 3 plus X? Do not say AX because 5 plus 3 is only 8. X is not like term, so 5 plus 3 plus X is actually 8 plus X. Okay, be careful. All right, so once we finish in translating all the items, I just kind of simplify for my magazine. It's easy for me to write in here. So let's write it in here, okay? Plus, so all these plus sign in red representing together, they are equal to 35. So the ads I translate to be X. Letters was 3 plus X. The bills was X. And the magazine, after I simplify, magazine is 5 more than 3 5 more than the later, so that will be 8 plus x. There you go. That's how we write out the equation. So once we write out the equation, now I'm going to treat them just a regular solving for x. So combine like terms. None of them has parentheses, but the left side I got like term I can combine. X plus x plus x plus another x is positive 4x. All right, 3 plus 8 is positive 11, equal to 35. All right, so since 4x is the only variable term, let it stay on the left side. So let's move positive 11 over. So that will be 35 minus 11, which gives me 4x equal to, combine like term again, 24. Is that right? Yep. Divide both sides by 4. My answer, x equal to 6. All right, so x equal to 6. How many adds did they receive? Adds is x, so how many adds? 6 adds. And the adds and bills is also 6 too, right? Because adds and bills were the same amount. So since this problem only looking for adds, so I just need to say the adds is 6. All right, so just a quick 3 example on how we using linear equation to solve application problem, what Mr. Chen called the comparison problem. Find the sentence that contains a translation word so we know what are the 2 items or more than 2 items being compared. Okay, so once we translate for the items, then we can write out the equation. And there is a difference between comparing between 2 different items versus more than 2 items. Okay, we kind of assign the variable x slightly different. Okay, that will conclude this lecture video. Thank you for watching.